Alright, so today we're going to be classifying quadrilaterals in the coordinate plane. So go ahead and get your worksheets out and we'll just do the first problem together so that you guys can follow along. So we're going to plot the following sets of points, and it says to A, classify the quadrilateral. And so you need to do that by giving it the most precise name possible. So parallelogram, square, kite, trapezoid, etc. Then we're going to list the defining characteristics. Defining characteristics are things such as parallel lines, or you can have like congruent sides, those kinds of things. Okay. And then we're going to justify our choice using the distance, midpoint, or slope formulas. If you do not remember these three formulas, please refer back to your notes, or you can Google it or find it on the internet somewhere. Okay, so figure 1 is point A, 3, 4. So remember, when you're graphing points, you have your x coordinate and your y coordinate. So x is along this axis and y is along this axis. So we go over 3 to the right and up 4, and then we plot our point. Okay, then we have 6, 0, 1, 2, 3, 4, 5, 6, and one of them going up none. And then C is 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, and 0, 0. Okay, so I'm going to label these points again. So 3, 4 was A is right here, B is right here, C is up here, and D is over here. Okay, and I'm going to go ahead and connect them. And my lines aren't as straight as possible. If you had a ruler, it'd be really nice to use that to make it look as straight as possible. So first, we're going to classify the quadrilateral. So we're going to guess what it is, and then we'll see if we're right and test it using our distance, midpoint, or slope formulas. So for me, it looks kind of like side DC and side CB are going to be congruent, and it looks like side AD and side AB are going to be congruent. So it looks like it has two pairs of congruent sides. And what do you know about where those congruent sides are placed? They are next to each other, which is adjacent. So what quadrilateral has two pairs of adjacent congruent sides? It is a kite. So this does not look like a traditional type of kite, but it has two pairs of adjacent congruent sides. So by definition, it would be a kite. So I'm going to say that it's a kite, but then I have to prove that. So I might have to go back and erase that later if that doesn't work. So I'm going to say it has two pairs of adjacent congruent sides. Okay, so I have to prove that these are congruent. So I need to prove that side DC is congruent to side BC. Well, if I want to prove that sides are congruent, which of these three formulas would I use? Distance, midpoint, or slope? Well, slope is just going to give us, if the lines were parallel or perpendicular, we could compare their slope. So I don't really need to use slope. That's for parallel or perpendicular. Midpoint, I don't need to know if something's in the middle, really. I just need to know if they're the same size, so I don't really need that one. And so distance is going to be the one I use. So I'm going to find the distance of side CD. So I know that the formula for that is D equals square root of x2 minus x1 squared. So remember, I'm doing C and D, which are these points right here. So if this is like my x1, y1, and this is like my x2, y2, Then I'm doing x2 minus x1, so 0 minus 3 squared plus, and then y2 minus y1 is 0 minus 6 squared. So I have square root of negative 3 squared plus negative 6 squared, which is going to be 9 plus 36. And then 9 plus 36 would be 45. And I can find the square root of that and get the decimal, or you can leave it like that, because if the other one comes out to be the square root of 45, then I know they're the same. So I don't really need to worry about it. So then I'm going to find side CB and see if they are the same. So C is this point and B is this point. So again, I'm doing the distance formula. And so I'm going to have x2 minus x1. So x2 minus x1. So 3 minus 6 squared plus, and then I have 6 and 0, so 6 minus 0 squared. And I come up with negative 3 squared plus 6 squared, which is 9 plus 36 again, which is the square root of 45. So both of those have the same distance, so those are congruent. So I'm going to go ahead and mark those on here with the tick marks to show that those two sides are in fact congruent. Okay, then I need to compare sides DA and AB. So let's see, AD, so I'm using points A and points D. So x2 minus x1, so 0 minus 3 squared plus y2 minus y1, 0 minus 4 squared. So 0 minus 3 would be negative 3, so I have negative 3 squared plus 0 minus 4 is negative 4 squared. So I get the square root of 9 plus 16, which is the square root of 25, which is 5. So then I'm going to try side AB and see if it's congruent. So AB, I have these 2 points here. So I have 6 minus 3 for the x's. So 6 minus 3 squared plus, and then 0 minus 4 squared, which equals 3 squared plus negative 4 squared, which is 9 plus 16 again, which is the square root of 25, which is also 5. So these sides are also congruent. So I'm going to mark those with 2 tick marks because they're different than our first sides. So this shape is in fact acut. Okay, so again, if you're doing the worksheet and you're checking to see if something has congruent sides, you're going to use the distance formula to measure how long those sides are and compare them. Okay, if you guys have any questions, feel free to ask, and hopefully you guys can work on this together and do well. Thank you.